You can configure bidirectional outbound interface NAT on NET Engine series routers to protect data within an enterprise network and ensure internal server data is not exposed. First, let's see what the internal server function is. In enterprise network scenarios, you can configure NAT so that users on a private network can access public network services. This hides the structure of the private network as well as devices on the private network. However, users on an external network cannot communicate with users on the private network. To address this problem, you can configure the internal server function on the private network. This function enables a NAT device to translate a public IP address to a private IP address based on a static mapping entry. The entry can map a private IP address to a public IP address or a private IP address and port number to a public IP address and port number. The internal server function operates in either address-level internal server mode or port-level internal server mode, depending on whether port numbers are translated. Address-level internal server mode translates only IP addresses during NAT. In this mode, one public IP address is used by only one internal server. Port-level internal server mode translates both IP addresses and port numbers during NAT. In this mode, one public IP address can be used by multiple internal servers, which are identified by port numbers. In this example, the port-level internal server mode is used. Next, let's look at the networking of bidirectional outbound interface NAT. As shown in the figure, the NE40E translates private IP addresses of servers A and B to public IP addresses before the servers communicate with the Internet. When server A attempts to access server B, server A sends a packet with a private source IP address of 10.78.1.2 and the destination IP address of 11.11.11.1, server B's public address. When server B attempts to access server A, server B sends a packet with a private source IP address of 10.67.1.2 and the destination IP address of 11.11.11.2, server A's public address. Before configuring the NAT device, let's look at the configuration roadmap. Step 1. Configure basic NAT functions, specifically, configure session table resources on a NAT service board. Create a NAT instance and bind it to the NAT service board. Configure a NAT address pool. Step 2. Configure mappings between internal servers' private addresses and public addresses. Step 3. Configure a NAT traffic diversion policy. Step 4. Configure a NAT conversion policy. Let's move on and learn how to perform configurations on the devices. The first step for configuring basic NAT functions is to configure NAT session table resources. NAT session table resources are controlled using a license. By default, a device does not allocate NAT session table resources. You can adjust NAT session table resources as required. A VSUI 160E is used as a NAT service board in this example. Set the number of session tables that can be created on the NAT service board to 16 million in the license view. The NAT service board is installed in slot A. Next, create a VSM-HA backup group and enter its view. Then bind the VSM-HA backup group to the CPU of the service board. Finally, create a VSM-HA service instance group and bind it to the VSM-HA backup group. The service board can be bound to a NAT instance only after the preceding configurations are performed. Next, let's see how a NAT instance is bound to a service board. As you can see, a NAT instance named NAT-A is created. After the VSM-HA service instance group is configured by running the service instance group command in the NAT instance view. The service board in the VSM-HA service instance group is bound to the NAT instance. Similarly, a NAT instance named NAT-B is created and bound to the VSM-HA service instance group. A user table needs to be created for a user when the user accesses the internal server. In port-level internal server mode, the public IP address in the user entry is obtained from a NAT address pool. Next, let's configure a NAT address pool. Configure an address pool named Address Group A that contains IP addresses 11.12.12.1 through 11.12.12.10 in the view of the NAT instance NAT-A. Configure an address pool named Address Group B that contains IP addresses 11.12.12.11 through 11.12.12.20 in the view of the NET instance NET-B. In this example, the port-level internal server mode is used. Next, create internal servers running UDP. In the view of the NET instance NET-A, set the private IP address of server A to 10.78.1.2 and the translated public IP address to 11.11.11.2. In the view of the NET instance NET-B, set the private IP address of server B to 10.67.1.2 and the translated public IP address to 11.11.11.1. As mentioned in the networking requirements, only PCs on the network segments 10.78.1.0 and 10.67.1.0, each with a 24-bit mask, can access the Internet and communicate with each other. To implement this, configure ACLs. Create an ACL numbered 3001 and enter its view. Create ACL Rule 1 to allow only users on network segment 10.78.1.0 with a 24-bit mask to access the Internet through NET. Create an ACL numbered 3002 and enter its view. Create ACL Rule 1 to allow only users on network segment 10.67.1.0 with a 24-bit mask to access the Internet through NET. NET traffic diversion can be implemented on inbound or outbound interfaces. In this example, outbound interface traffic diversion is used. An IP address 10.67.1.1 is configured for the outbound interface GE300. Packets matching ACL 3001 in a traffic diversion policy are diverted to the NET service port. An IP address 10.78.1.1 is configured for the outbound interface GE301. Packets matching ACL 3002 in a traffic diversion policy are diverted to the NET service port. Finally, configure a NET conversion policy. Run the NET outbound command in the NET instance view to divert traffic matching ACLs 3001 and 3002 to the service port for NET processing.